And these ones, just like the last one, want you to take a look at them first and see how fast you think you could guess and check and answer. I actually think B looks like it's maybe doable. At least for one answer. And then we're going to go and use that zero product property. So what does that mean? Well, if I make one side equal to 0, so in other words, I'm going to have to add 30x to both sides. If I can change this to multiplying, then something has to be 0. This looks like a level 2 factor because of 3x squared, but if you look at it carefully, do you notice that there's a factor of 3 in each of them? If there's a common factor, factor it out. It'll make your life a lot easier. At this point, it's got to be x and x. 25, so the outside and inside makes 10. 5 and 5 seems to be a good idea. We need a plus 10, so this would have to be a plus 5 and a plus 5. Does it still give me the plus 25? It does. Can you see that now you have 1, 2, 3 things multiplied together? 3 times x plus 5 times x plus 5. Can the 3 ever be 0?
No.
No. The 3 is always 3.
You can get rid of it, though.
You could divide both sides by 3 and just, it could go away. Yes. But this one can never equal 0. Could this one equal 0? So this one never. But this one, yes. What would x have to equal? -5. What about this one?
Same thing.
Same thing. In fact, this one has only one solution. Some of ours had 2 solutions. This one only has 1 solution. In fact, next year in grade 12 pre-calculus, we'll say this has 1 solution of multiplicity 2, because the same solution happened twice, but it's still only 1 solution. And this does interesting things to the graph when something happens twice. But that's next year in grade 12 pre-calculus. But for right now, there's only 1 solution. X has to be -5. The second one. Again, I see a quadratic. I'm going to make one side equal to 0. Can you factor this? Yes. There's a common factor. What can you pull out of both of them?
5.
And?
X.
And an x. Leaving you with an x minus 4. Here's your multiplication. Multiplication is right there. Can the first one ever be 0?
No.
Yes.
Yes.
5 times 0. Zeros. And this is why I thought, this first one, I thought, can you see really, like if x is 0, this side is 0, this side is 0, would work out nicely. Oh, I made a mistake, right?
Yeah.
Thank you. See, the minus 20 should be a plus there, which will make this a plus there. Can the second one ever equal 0? Yes, when x is a -4. And if we double check the original answer, -20 times -4 would be 80. -4 squared is positive 16. 16 times 5, 80. Okay, you'd have to know your 16 times table. A little bit trickier, right? If you were just trying to guess and check. The zero product property gives us a way, we have to be good at factoring, but it gives us a way of solving these without having to guess and check. And when you have a method, that could be a lot faster. Okay, ones to circle on this one. 8, 9, 10, 11, 13, and 18. And I put a star beside 18 because it's probably a little trickier.